time. What we need is a bottom-up approach where countries list what they actually want from their systems and identifying their problems. So some countries have big problems with deforestation, Indonesia. Other problems have huge problems with forest degradation. The Philippines is far more driven by degradation than deforestation, for example. All of them have different solutions. Some could be government policy, some can be private sector engagement. There was a very interesting comment before on, I think, in the blockchain discussion about tracking supply chains for agriculture. That's a really interesting example of the private sector trying to get involved in reducing emissions from deforestation themselves. Importantly, they also have hugely different types and availability of data. The vast majority of them have pretty poor data collections into the past, so they're looking at using remote sensing because that has a good time series that can go back, but they have real problems with this, and it's actually pulling these data together. Actually pulling that data together in a coherent way is not easy. Here is what we normally see. The existing systems are really coarse, and they're really thought about from sort of a very 1980s, 1990s perspective. Generally done in spreadsheets is the best way of doing it, and when you see a bit further down the track, you'll see why a spreadsheet is not particularly good for this. They really don't allow for a continuous improvement, and that's a really key part. No country is going to get this perfect the first time. We actually need to have systems in place that they can continually add new pieces to every single year to make it better and better. The old systems can't take advantage of any of the new technologies properly, all the remote sensing, all the new carbon models. And again, they really don't deal with other issues. They can do emissions, but they don't help you with other issues that these countries are interested in. So as an example, I have this beautiful multicoloured splodge on the side here. This is a part of Africa with Kenya in it. This is an example of a map that estimates the amount of biomass in a forest that's used in a standard system. So you can see it's pretty coarse. That's the type of dynamic we're starting to get out of remote sensing. That's Landsat, that's 30 metres a pixel across all of Kenya, multiple land uses occurring. So you can see there's this huge change in the data that we're actually starting to see become available to these countries. This is one of my favourite diagrams, or cartoons, and it really sums up the problem. We have all of this data, we have all of these reports and things we want, but there's actually no real systems that sit in the middle to bring it all together. People just assume they're there, and they're actually not. And this is a big, big problem. What we really need is a good analytical framework that allows us to do that, that's generic, that allows countries to actually make it fit their country's circumstances, but not have to spend millions of dollars recoding the same core piece of software. It's important to think how we actually got here. So as I said earlier, Kenya is one of the key collaborators. One of the reasons they're the key collaborators is they're actually out ahead of the pack. The Clinton Foundation started working with the Kenyan government a number of years ago to actually sit down and discuss what is it that your government needs from such a system. And they identified a huge number of issues, but in particular, again, food security, agriculture. These kept coming up. Emissions was important for them, but nowhere near as important as those issues. Once we had all of those policies and needs down, we assessed the existing integrating tools, a donor comes forward to an organisation, they say, can you build me a decision support system or some remote sensing platform? Here's X million dollars for 3 years. Software gets built, people run it for 2 years, there's no more money, software gets put on a shelf, disappears, repeat. Been done dozens of times, and so we really want to avoid that problem. To us, that's why we look straight to open source as the key. We want to make sure also that no one government owns the system. All governments using it have an ability to come in and make requests about how that will get managed, and one of the examples of that is something you can look up called the Global Earthquake Model, which numerous countries collaborate on to keep the core simulator running, and then they attach their own country-specific examples to that, and they all tip in a little bit of money every year to keep it going. But the key thing with this software that's very different is that we really, really, really need strong governance. So it's been mentioned a couple of times before here that the tools that have been developed could underpin financial mechanisms. We're talking about billions and billions of dollars per country. A small bug, a small problem actually causes huge issues. It also underpins countries' commitments going off to the UN and saying we will reduce emissions by this much. If there's a mistake in the code that causes problems, that's going to be a problem for everybody. So we really need a strong governance structure, and that's where we've really been interested in talking to the Linux Foundation in particular, because of all of that experience of how we could actually bring that together and actually do this properly. So a little bit of information on the ongoing activities that we have, just for background, because we are still very much in an early development phase. So the Flint development is ongoing. We're planning on doing the first full run for Kenya at the end of April, but that does not have interfaces or any of those sorts of things. It's driven by our own data formats, text file configurations, those sorts of things. But importantly, the collaboration with the Canadians has allowed us to actually replicate their system in the new system and show that what their system produces is exactly the same as what we're producing, and that provides a high degree of confidence that we're actually getting the same core infrastructure right. We've had a lot of interest from Indonesia to try to move to these tools. They're currently using the Australian system. The Australian system, whilst it does the job for them at the moment, has far too many limitations for them to continuously improve their own national system. So they are looking very actively at something newer, and this is the main one that's available at the moment. As I said before, we're really interested in the governance design. We really need to get involved with the stakeholders much more, including yourselves, and importantly, we need to start putting together some funding proposals. I'm sure that's fairly familiar. Just a very quick list. I've seen lots of logos today, so our list is a fair bit shorter at the moment, but these are the groups that we've largely been collaborating or working with on this. But it's a very different list. Again, you can see there's no private sector up there. There's universities. Baker & McKenzie, the law firm, would come in, but it's under their philanthropic arm. This is largely very science-based at the moment, and it's trying to take it away from that and move it again into an actual operational system. So, as I mentioned at the start, we're really looking for assistance here. And there's three main things that we're looking for. We want collaborators on development. At the moment, there's 2 key developers in Australia, there's 2 in Canada. That's the team that's working on it. So, and we've been working very much on the core systems. We haven't been touching things like interfaces. We haven't built continuous integration systems for this yet. We also haven't built all of the data management systems that are really, really required to underpin this. So there's still a lot to do. So we'd be really interested in collaborating with people on that. As you could probably see from the earlier slides, this requires a lot of compute power, but it doesn't have to run all the time. So it's actually really well suited, potentially, to the cloud. And that is a really interesting part of where we want to take this. The only issue being is that governments are a bit wary of that at the moment that we talk to. So you get this sort of funny situation where they don't want to buy a whole lot of IT equipment, but they don't want to go to the cloud. They want to run everything on a laptop. So there's a bit of work there to think through. And of course, financial support. So there's a website there, an email address, and we also have a little unconference event happening after this session, and we'd really appreciate it if anyone's got thoughts or views. If you could come and please talk to us, that would be fantastic. So, thank you very much.
Systems. That was later acquired by HP, where he headed their cloud business. And again, not to be contained, Martin then said, I've got to start I've got to go work and be the CEO of yet another company, and has landed at HackerOne. HackerOne is a really interesting company that is a leading vulnerability coordination company and is best known for their bug bounty platform. And Martin Mickos is going to talk to us today about, once again, how to make the internet a more secure space. Come on up, Martin. We also kept Martin from skiing today, so this is a very big honor.
Thank you, Jim. Thank you. How hard do I need to click? Okay, really hard. Hi, everybody. It's all about security now, but unfortunately, security is malnutrition and poorly served, and there's an $80 billion market for security products that are not doing their job. And it's not anymore the dark side, it's becoming the light side, because security is becoming a very positive part of what we do here. And I'm certainly here to repay some old security debts, because back in the 90s when Linus started with Linux, he didn't think about security. And when MySQL started in 1995, we didn't think about security. We just built an easy-to-use, fast, robust database. And because on the internet you had just fun things that were not that serious. Today, however, the internet and the connected society is winning, and everything that's vital in society is running in a connected system. So the exposure is much, much larger. And now with every system and everything being connected, the risk is even bigger. So people like me, we have to go back and clean up what we created before and create some security and turn it into a positive trade. It doesn't have to be snake oil. It doesn't have to be just adhering to compliance and doing cover your ass. There's a lot of positive measures you can take in security that make your systems and your building blocks secure. Okay. I sent an updated slide deck. This is not the updated one. This will be a faster talk. That's fine. I will speak to the other slides. But this is one of my slides, absolutely. I recognize it. I was going to tell you that what I'm doing, for the past 15 years, I've been building business models that empower developers and hackers, and really empower them, because for some reason I believe in hackers, although I'm not a hacker myself. And I want to empower them to meet really difficult challenges, to do the right thing, and to be properly paid for it. And that's what I did as CEO of MySQL, then at Sun Microsystems, CEO of Eucalyptus, then head of the cloud business at HP, and now CEO of HackerOne, where we have a community of thousands and thousands of hackers in the world who hack your systems at your request, and you pay them a bounty when they do a good job. And customers include General Motors, Uber, Twitter, the Tor project, and so on. So that's what we do here today. And we came into this industry thinking that the security industry is fundamentally flawed. secrecy around security. In the traditional security space, there's always secrecy. You keep your flaws secret, you keep your problems secret, you keep your people secret, you don't tell anybody about the problems you have. That's completely wrong. And mankind has known for a long time. Go back to Kirkhope's principle from 150 years ago, where the design of a system should not require secrecy. But then you take the NIST 800.123 definition, where they say the same thing, that the design of a system and the security of a system must not depend on secrecy of the components or their implementations. Keys can be secret, but the implementation needs to be open for us to reach full security. And this, again, I realize I'm preaching to the choir, but many of you represent companies where they're still thinking that whenever there's a vulnerability, whenever there's a bug, you need to keep it secret. But it is in openness that security truly happens. This is also why the Linux Foundation is one of the best equipped organizations to deal with this, because the Linux Foundation was built on openness from the foundation, and everything they do is open. And we've now seen that that is the best way to build full security into systems. Of course, full security doesn't exist. As long as human beings are creating systems or creating robots that create systems, we will have flaws and bugs and vulnerabilities. That's inevitable. And it's interesting that what I'm learning now at HackerOne, that we talk about vulnerabilities, it's more than just bugs. You can get a vulnerability from a configuration parameter, from how you deploy, from how you use it, from how you define the processes. So it's not just a strict definition of a software bug. There are many other things. There can be software without any bugs that still is vulnerable because there's some vulnerability in how it is being deployed, for instance. Security is also achieved in collaboration. You all have clearance to work on cybersecurity. We all have clearance to do that. Millions and millions of people in this world can help work on cybersecurity. But again, in the classical world, we talk about special teams, red teams, teams with clearance, and we think that security is best achieved by small teams. Sure, you may need a small team, but you don't know who you need. But when you go outside of your own organization and collaborate with others, you'll find the expert who can help you exactly with what you need to do. And when you collaborate broadly, you get into this stochastic power of crowdsourcing and the wisdom of the crowds, that an ill-defined problem will find its solution, because the crowd out there is so uncontrollable that they will test everything, they'll try everything, they'll do everything, and sooner or later they'll find the bug that no test team could find, no scanner, no pen testing, no QA team, because it was so weird that it took sort of an external person without much internal knowledge to find it. And when we talk about collaboration, we must always remember that collaboration is not about all of us agreeing. On the contrary, the power of the open source movement is that we collaborate even when we disagree. And I haven't seen many communities that disagree more than open source. Well, now I have, the security world. But the power of good governance of collaboration is that you can collaborate even when you disagree, and you have a method for resolving the conflicts, and that's how it works. So it's not dependent on goodwill, it's not dependent on altruism by anybody. Everybody is acting for their own interest. Everybody might disagree with everybody else, but stuff still gets done. And it's the same thing in security, which we are seeing now. And you could say that what happened to software in the past 20 years is now happening to the security space. It's opening up, it's becoming more collaborative and much more powerful. So whatever principles we follow in security, there's an easy way to destroy security, and that's to be slow. Today the world is connected, and whatever there is out there that's vulnerable, you have to act fast.
You have to be an agile organization that can fix the bugs quickly. And not only fix the bugs quickly, first you must identify them quickly. So quickly go out there and ask the community help you find them. Then you need to fix them quickly, and in all of this you need to communicate with your hackers, security researchers, finders, whatever you call them, very quickly. Because they are impatient people. And if you don't respond to them quickly enough, they lose interest and go somewhere else, and you miss the value that they are bringing. And the difference between one single hacker paying attention to your system or not could be the difference between security and an enormous breach where you lose personal information, privacy, money, operational readiness of a production system or something. So it's very important to act fast. And of course the adversary here, whoever it is with malicious intent, is learning to be faster and faster and faster. And us who are on the defense side, we have to become faster and faster and faster, fix these things quicker so that they can't be exploited for malicious intent. And we saw that with Heartbleed, we've seen it with really serious problems that we have in the open source community that we now need to fix. And that's what I mean by the security debt that we are carrying. Back in the 90s and 2000s, we were like open source hippies. Everything was fun, everything was allowed, everybody could participate. And now we need to be responsible open source citizens and build security into the whole framework of software development. So software needs to be part of the software development life cycle from the very beginning. And I'm a sinner here, so I'm admitting that I didn't think like this until some years ago. But the only way to build truly secure systems, and like I said, there's not 100% secure systems, but truly secure ones, is to start from the beginning. In the software design, in architecture, in how the computer scientists are trained, security needs to be an everyday part of their work. It has to be the essence of what they do from the very start. And I think that's happening now in our educational systems, and the new developers and hackers I see growing, they have that. They take it for granted and they think about security from the very start. But that is the only way to build systems that are resilient. And you have to do it at every stage. It's cheapest in the beginning, but then you do it all the way to the end. And at the end, when you have your system in full production use in the connected society on the internet, then you run a bug bounty program that will be the